I unmuted myself, I forgot. Okay, thank you. It's not too late. All right, so creating the mass matrix. M is M1, J1, transpose J1. Let's just do that separately so I don't have to write M many times. Then M2, JV2 transpose JV2. I've already posted the annotated version, so you should have access to all of these notes. This is just me writing it again. Okay, so this is your, so I created this parameter here and this parameter. Now we have to do the other one for J omega, which we're gonna use our J omega 1 transpose IC1 and J omega 1 multiplied by J omega 1. These are all matrix multiplication, right? If you do that, you will get IZZ1, 0, 0, 0. And for the other one, J omega 2 transpose IC2, J omega 2 is IZZ2, 0, 0, 0. Now that we have all of them, we're going to find total mass matrix. M1 L1 squared plus IZZ1 M2 D2 squared plus IZZ2 0, 0 M2. So this has to be symmetric and square, right? It's symmetric and it's a square. So everything turns out so far. Now the next thing, you have to find the matrix B and matrix C, right? From Christoffel symbols. Now, before I do that, I'm going to identify M11, M12, M21, and M22. So this is M11, M12, M21, which is equal to M12. That's probably I had a lot of subscription things last class. I just put, if it was M21, I put M12. Then this is M22, correct? Yes.
If you scroll up a little bit, M1 L2 squared, L1 squared.
L1 squared. All right. So M is there now. B, I, J, K. We had a formula 1/2 M, I, J, K plus M, I, K, J minus M, J, K, I. M, I, J, K, we know is partial differential of M, I, J, the first two, with respect to the third, Q, K, so the third subscript. Also, to note that, note, B, I is 0, and B, I, J, I's, right, is 0 for I greater than J. Because the joints after joint I is not going to appear in your Jacobian, so the differential are going to be 0. So we're not going to even calculate those. So we only have a few to calculate. That's the beauty. Because we come from a symmetric matrix, most of it also will be similar. Here, we are going to take a look and see for this manipulator. If you look between M11, M12, M21, and M22, which one is, it will vary with your joint variable? Which one of those four? M11 only, right? So we're just gonna focus on M11. So we're gonna get partial derivative of M11 with respect to first joint and second joint. Now, first joint is what? Theta 1, right? Do you see any theta terms in there? No. So it's only with respect to theta 2, right? The second one. So I'm just gonna write that. So M112 for second joint, M11 with respect to your Q2, which is respect to D2. Does everybody understand what's happening here? Yes. So I just didn't do a lot of things. Looking, observing, understanding what my problem is, just save time. Otherwise, you could go and do the math will hold. You just get zeros for everything. So here, if you calculate this, you have 2m2d2. The page so we can continue over here. All right, so with this, so now I have m1, 2, I can start calculating BJKs, right? So B112 IJK, right, is 1/2. Can you speak quietly, please, at least? Thank you. M112 minus plus M121 minus M121. We know these are zeros because K, we said that for any of other M's, M1 to M21, the differential is going to be 0. So we know that's 0. So we're not even calculating that. So then B211 is 1/2 M211 plus M211 minus M112. Again, these are zeros because the partial differential is not impacted by the joint variables. So B112 is 1/2 M112, right? So is 1/2 2 M2D2. So it's M2D2. This one is 1/2 negative M112, which is 1/2 times 2 M2D2 negative. So it's negative M2D2. Now matrix B is going to have 2 elements, 2B11, 2, 0. We are following the big matrices that we saw before. So this is going to be 2 M2D2, 0, and matrix C is going to be 0, B122, B211, 0. We said that BIII is going to be 0, so the diagonal is 0. Here is 0, 0, negative M2D2, 0. All right. Matrix B is done, matrix C is done, so that will take care of our Coriolis and centrifugal. Yes. Which one? M211 and M2, these are 0 because if you look at M21, that's 0, right? So partial differential of 0 to respect to anything is going to be 0, but so we didn't calculate it by 0. Same for this one, M22. So M221 and M222, they're 0, right? M211, M212 are also 0. M121, M122 are 0. I just didn't write it. So if you had something, because this is going to be symmetric, so if you had any value for M21, you will have it for M12, it will be similar. So kind of those two, you do it one time and place it for the other one. So it's kind of like, I would always look at the matrix and see which joints are impacting the mass matrix, and then calculate only the ones that like you need. All right, so now matrix V, which is our centripetal and Coriolis, is going to be, so 2M2D2, 0. This is multiplied by theta dot 1, E dot 1, right? Plus, so this is the, don't forget this is step. M2D2, 0. This is the square of them. D dot 2. Now gravity, how do I calculate gravity? G is negative. We have also based on Jacobian transpose, M1G, we already have that, plus Jacobian V2 transpose, M2G. Now, what is our vector G? Let's go back and look at that. G in the phase frame, there's a value 9.86, right? We also need the direction of our vector. So based on our base frame, what is the vector for G that represents G in base frame? Yes, and then you can bring G out, so 0, -1, 0. So I'm gonna write 0, -G0, but you understand how we are multiplying the value, the magnitude, and the vector itself. So G in frame 0 is going to be 0, -G, 0 transpose, right? Now, so creating G, negative L1, S1, L1, C1. So it's sine theta 1, cosine theta 1. This is transpose, that's why this is sideways. Then 0, negative M1, G, 0, negative D2 sine 1, D2 cosine 1, 0, 0. This is kind of the same line. And then 0, 0, negative M2G, 0. This will give you M1 L1 plus M2 D2 G cosine theta 1 and M2 G sine theta 1. So now you have all of them, you put it in the form. So matrix M multiplied by theta double dot 1 D double dot 1 plus, I'm not going to write that Q and this matrix. So I'm going to write Q and Q dot because this is theta 1 and D1. This is D2. Yeah, D2. This is theta 1 and theta dot 1 and D2. But in the annotated version, I have written them. Theta dot 1, D2, D dot 2. Plus G is tau. What's the dimension of tau? How many taus we have? We're gonna have 2 of them, right? One that is respect to theta double dot 1, the first inertia, right? First joint. The other one is the second joint. So tau 1, tau 2. Then you can find it if you had any external forces or torques, you can find those values. All right. So I don't know which method do you prefer. If you remember the first method, that how we drove the dynamic for the same joint. Do you remember what we did previous week, last week? Yeah, apply Lagrange and find kinematic potential energy for every joint. We did that. So in my opinion, this is more straightforward once you figure out the Jacobians. If you have the Jacobian, this is very straightforward. So if I would code for a robot, I'll probably use this method. This is based on the algorithm, the explicit method. So every time you hear you have the explicit method is where you can code based on that. It's easier probably. But again, depending on the problem at hand, choose the best method. All right. So your next homework, you're going to see an example that I'm asking you to find the dynamic, and I will leave it to you. You choose whatever method you like better. Or use both, and then one of them is not going to fit, but it should fit. Both of them have to give the same solution. Yes. Here, negative.
Yeah.
Yeah.
I know how to calculate. I know the formula.
Okay.
How do you calculate?
So this is J transpose, JV. I already calculated JV1. I just transposed it.
Check with the formula X outside, and I got the 0 for the second.
Right?
You multiply the first one, gonna be 0 for the second, so right, and the second one, you multiply, we'll get 0.
So negative. So there is a negative behind it, right? Negative, which applies to all of them. Negative L1 sine theta 1 multiply by 0. So you first multiply by that. So from this first side, you have negative L1 cosine, well, all the negative will be, so L1 cosine 1, M1 G1, G from this one, right? And then you have to do the other one, you'll get to this. At the end, when you put them together, both of the dynamic, they look the same. I can do this again, check, but I can do it right now, but it would take from the exam time that I will explain. Your choice. I can talk about this, but we can do this again and then see what it is. This is from your book, so and it should make sense. It should fit this. It should become this. It will become this. But all right. I know that you had a class participation, so if you've done it by the mass matrix, you were fine. That was what I expected because you didn't finish. Those of you that followed the lecture and could finish, kudos to you. So for that, it's simpler because you don't have any J omegas, right? You didn't have any angular Jacobian because it was a Cartesian. So in calculation wise, it was simpler, but you still had to follow and find your J1, JV1. And it was also, it would be a good practice to see how to calculate Jacobian. I'll post the solution. So there's another example for calculating Jacobian. That being said, I'm gonna stop sharing this one. I'm gonna bring up, but before that, maybe I should go here since I'm recording this. So I was a little busy doing all of this. So posted the practice problem for Jacobian. CP7 solution is there, homework 3 solution. It was on my file, forgot to give you access. Here's the solution. Practice problem for equation of motion, but don't worry about it now. Review next week because you're probably focused on the exam. And then, yeah. So in exam review, I posted the exam practice, which I'm going to talk about. Okay. Now let's share from this one, because this has the updated questions. Because would it be nice to have harder questions for you guys, but oh well. Next time. So it will be the same structure of exam 1. The difference is you can bring your calculator. I won't promise that you will use it, but you can bring it. For you, I didn't update the LBS, but it says here you can. 1-page cheat sheet, one size, A4. Bring pen, pencil. I will bring extra paper for you if you need it. Write neatly. Show all of your work. Don't assume that I know things or is clear, obvious, right? And I generously deducted point last time, so you remember. For this one, I would like you to write your start time to 3 p.m. and whenever you finish, just to gauge if this is, because I tried to, for the actual exam, to make the question easier. So I'm expecting everybody will finish, you know, in ample time, but well before the like 4 p.m. Don't just try to write at least your finish time. That's just for my little survey for this quiz. There will be short questions. So the material is from DH table, right, to the end of numerical values for inverse kinematic. But since we didn't really do any the practice problem or homework for numerical or analytical, there are not going to be any questions from there. But you should have the knowledge of what inverse kinematic is, right? Does that make sense? So for the problems and for conceptual questions, you should understand what things are. But for problems, it's DH table to the beginning of an analytical method, right? So there will be 3 questions, exactly that point values. The third one is a short problem about Jacobian. You can do it quickly if you understood the concept. So that will be a quick check. Then there will be 3 problems. Problem 1 will be frame assignment. So I will give you a robot that doesn't just has the joints, and there's no frame assignment. Now, if you are, so there will be frame assignment and creating DH table. I don't want you to go to use big matrix for this question, because this is kind of a longer question, so the DH table is going to take forever. All right, so read the question, will only answer the question I asked you. Adding extra information, you'll lose points. I think some of you know that. Yes.
When you're finding the reference point for like the rotational point, does it matter where you what direction to access?
Yes. So you have to, because when you create DH table, you use X direction to calculate two of the values. So X and Z are important. So you have to show the value for X and the direction for X and Z for every frame. Don't forget your base frame. You can put on your first frame, or you can put anywhere you want, but then it would reflect your DH table, right? Your two solutions might not look the same because the direction of X sometimes changes depending on the situation. So afterward, if you're comparing and you have different solutions, don't worry, both of you might be right. Okay, so yeah.
Can you go through why you're sending X direction, the other direction?
Yeah. So I try. So the best thing to get the most point is when you start, you know the direction of Z, right? The direction of rotation, direction of movement. So we are following right-hand rule. So don't ask me why it's not going down, because you're following right-hand rule. So anytime that you see that cylinder, right-hand rule Z, Z, and then the direction. So I think in the exam I also showed with the box, but I would there is a big surface shows you that it's going that way. Also, the end effector will show you which direction it's going, right? So it should be clear. Now, do that way. When you assign your Z's to assign your X, you have to find the direction of Z1, Z2, and then find the the common perpendicular, right? Mutual perpendicular. Now, for that case, Z1 and Z2, there are two cases for your X. One, so if Z1, Z2 is a plane, X1 could go into the plane or come out of the plane. So both of these are correct. But once you have that, your DH table will be based on that. So I will look at your DH table based on the frame assignment of your solution, right? That's how specific everyone's exam gonna be. Well, it's gonna be like two methods, two ways only for this one. Now, so I find the direction of X1, I showed you the cross, so it's going into the page, right? But you can do something like that and show me what you meant. So I prefer if you show everything in detail. It's easy to grade. If you miss something, I know where it came from. Grading will be different, right? If you write that or that, but you have to choose which one you're going with. I'm going into the plane. That's why I put a cross on my X1. Then on the second one, it's Z2 and Z3, right? So Z2 and Z3 are parallel, like are on top of each other. Now, the common mutual is so many cases, right? Any direction that it's perpendicular, which is perpendicular, is going to be your solution. Again, so you will identify that. That would be your X2. But here I wrote like any in this direction about the circle around it, it will be acceptable. But I chose one direction. Then for my third one, since it's my last, so Z3, I know that for my, since this case especially, this is a prismatic, I know it only has movement in two direction, right? And immediately after that, my end effector. I know that I'm going to follow end effector or whatever my third frame is. Then Z3 and Z4 will be in the same direction, right? It's the same case. I can pick X in any direction. I will usually pick it with respect to the previous one, because when you're calculating, you have less things in your table. But again, if you grab that direction for X3, for example, if you put your X3, say, you know what, I want X3 be here, fine, because this is your Z4, right, ZE. these two are again parallel or aligned. So your x3 can be anywhere. So you can say here, you can say here, it's fine. But then these directions will impact your DH table. Does that make sense? So that will be question 1. Then you will go and find DH table. So you have to bring this guy with you. You don't have to write it for me, it takes time, but you have to have it in your sheet. All right. I like to do this again, because I've seen even in your exam, you calculate something, when you bring it to the table, you bring the number wrong. But if it's here correctly, then if you made a like mistake there, if like one error, I can just not look at it. But if you just put the value directly, I don't know, like how did you came up with that? And it's like, oh, I meant -1 or +1. It's like, I don't know. So the more information you put for me, the better. All right. I'm not a harsh grader if you provide information to me, but if you don't, I don't provide great points. All right. Question 2 would be Jacobian. Yeah. I haven't posted solution because if I did, nobody would be here. I'll post after class. It's like annotated version. I will post this one. Yeah, because I'm not going through everything because you're going to study. So it doesn't make sense if I go through everything. I'm talking about your approaches. So if you see a question about DH table, your approaches, let's find Z1 first. Then let's find X1, X-axis first. Then let's create the DH table, put the base frame on frame 1. So it's easy to find, most things are going to be 0. Let's put end effector frame on my last frame, right? In your exam, you might get a bigger robot, but you just have to like do a little bit of calculation like 2 times. So 5 to 10 minutes. This took me, question 1 took me 5 minutes, but I'm giving you 15 minutes. If you have done this enough time, 15 minutes is more than enough to do that. Because a lot of it, you really don't need to draw. This is just to make sure that you have everything set. A lot of it becomes 0. Question 2 is going to be Jacobian. Read the question well, all right? You might see a slightly different question. For this one, it says consider PPP manipulator. So this is Cartesian, right? Find the Jacobian matrix that relates the joint velocities to the linear velocity of end effector. I'm specifically looking for linear Jacobian, JV. Right? So if you calculate J omega and say, oh, that's going to be all 0, I'm going to give you full Jacobian, you're going to lose points because that's not what I asked. I want to know if you understood what that sentence means. All right? If I say find the position of the end effector with respect to base frame, I mean the position X, Y, Z with respect to base frame. All right? Now, to find Jacobian, you have different methods, right? If you have a planar robot, like the RR that we had, if all the direction of the rotation are the same way, just use geometrical. Find X, Y, Z, direct Jacobian. That's the easiest way. If it wasn't the case, then you can use the velocity propagation. That's probably your next best solution. It's faster. If you didn't like that, use DH table. Find the final transformation. You have the position of end effector. You find all the z-axis throughout, and then create your Jacobian. That just takes longer. I think for your exam, that's that's not the best policy to use DH table, unless the robot looks very simple. It has 2 or 3 simple things like this one. So this, you could go DH table because it would be like really simple matrices. There's no sine cosine because there's no rotation. There's a bunch of numbers, right? So it would have been fast. But what I did is I'm looking at this and I said, okay, I can just find the position of my end effector. So here, there's no linkage. So actually, all of them are on top of each other. They just move, right? They're Cartesian. So I'm gonna say, okay, X, I'm writing in base frame. X of my end effector is gonna be D2, right? Because in direction of X0, in this direction, that's the only displacement that's happening. So X is D2. y in this direction going down, negative d3, and z in this direction, I only have d1. So this is from observation. So to understand which method to use, like spend a minute or two to look at your robot, see which method is better. Now that I have x, y, z, I can find x dot, y dot, z dot, and you can see that they're all based on my joint variables, right? So d dot 2, negative d dot 3, and d dot 1. All I have to do is use direct method for Jacobian. Find the values. This is simple, kind of expected. If you go from each table, you see that you will get a bunch of numbers, but that's also quick. To make sure what you have is correct, I just did this. X dot, this is just extra step. You can't say to evaluate, I did this. So X dot is this Jacobian, right? Jacobian times your theta dots, right? So I got the same thing. Now, if I go back, if you look at this point, the direction in X definitely gonna be only d dot 2, right? The velocity of that second joint. The direction along Z0 is only gonna be due to this, so the velocity is d dot 1 here. So that's kind of, and then you go check and it's like, okay, that's what I got. So that is kind of an evaluation of your solution to make sure it's correct. So if the robot was simple, you can kind of do that to make sure your answer is correct. Don't spend too much time. If you couldn't get it, it's fine. But usually for simple robots, you can understand which way the robot is moving. So the velocity at this is impacted by those joints. The question for the exam will be simple as well. It's not going to be difficult. The reason is because of time. Otherwise, I would have loved to give you a more complicated one. This could have been easily a take-home exam, but we discussed and some of you didn't like it, so you do it. This question, if you try to do it and your mind was like, what is happening? For this one, either you have to use an analytical method or find the position using forward schematic, then using the schematic. So I had to find the table. It would have been like 1 hour at least, sorry. So I changed it to RPP robot, okay? So nobody will design this robot because why? What's wrong with this design? It is redundant, right? But it's my very easy way to fix this thing like 10 minutes before class. I was like, oh crap, I'm not gonna solve this, you're not gonna solve it. So I changed that second one to a prismatic, but I still solved it. And you'll see that if you solve in this, D2 and D3 are gonna be dependent in one equation. When you look from top, again, because these two are aligned, right? Their axes are aligned, so they're gonna always move together. There is no way that you can find them. So that actually, well, redundant, but if your robot moved such a way that the two axes of your rotation are the same, or axes of prismatic translation, that's your singularity. Basically, you lost one of them, right? So they always move together. But to just finish and show, I did that and showed you that D2 and so I found theta. It's easy, and then I explained kind of observation that D2 and D3 are not independent because D2 and D3 are aligned, redundant, so you can't find any schematic. You could say, okay, I'm going to send D2 3 centimeter, and whatever is left is D3. Yeah, but you could have just one that goes the whole way, right? So this is just my last minute cry for help. But if you are going to do this, it will take a while. Your exam is going to be in this level, have a solution. It wouldn't be without solution. There will be something that you have seen, you might have done. You know, so that's about it. That's about exam. Usually my exams are not about being hard. My homeworks usually are harder. The exam is just the basic fundamental. I don't care, this is a 5,000 level class or 7,000 or 3,000. I always ask fundamentals. So if you get off, it's like, this was easy. It was easy, just move on. I don't doubt yourself because I know a lot of good students, they sit until last minute. I'm like, why? This was supposed to take 15 minutes, get out of here. It will be more than 15, but if you say, oh, these are simple, I've seen them. This, yeah, that's it. Okay, so don't stress about it. Just have fun. I'll get to your body after the exam. Yes, Cam?
Can you go back over number 2? You said that pay attention to the question asked.
Yeah.
Like what question could ask?
So that question said, find the Jacobian matrix. So if it was just find the Jacobian matrix for the end effector, that would have been 6 by whatever number of joint is. But here I asked Jacobian matrix that relates joint velocities to only the linear velocity of end effector. So top 3.
Okay.
That's so if you would have done the whole thing, I would deduct point from you because you didn't understand what I'm asking. Okay, there will be something that you need to read in the exam. But for this case, the other 3 are 0. Yeah. That's about that. Let me, yeah.